Hey guys, so in this video, we will see how is SSL different from TLS. So why are we nowadays using TLS? TLS stands for Transport Layer Security. SSL stands for Secure Socket Layer. So why are we using nowadays TLS more and why is SSL depreciated? So let's understand this with an example. So let's say you have a lot of money and jewelry, gold or silver in your house, right? And you have put it in a locker, right? You wanted that locker to be safe. So what you will do? The first thing you will do is that you will put a lock, right? A simple key lock, right? So that this simple key lock is basically SL, right? And then there's a different lock where basically that lock is having 3 4 layers. For example, first you need a face recognition, then you will need a thumbprint, and then after that basically the door is open, and then inside that for main locker there is a pattern code to open that, right? So basically there are three type of lock just to open that locker, right? So there are multiple features for that lock, right? So multi-featured lock it is there, right? So this multi-featured lock is basically TLS. Why I'm saying that? Because TLS has more features than SSL and it is stronger than SSL. That is why nowadays every application, every organization is trying to support. If they have been using SL also, they are now moving to TLS, right? So that is why SL is depreciated nowadays, right? The common thing between them is that both of them support digital certificates. So basically, digital certificates are used to perform verification and validation whether the client exists or the client is correct or not, and the server exists and the server is correct or not, right? So there's this process that happens in between to verify that both the parties are the correct parties that they meant to be, right? So this is why we are using TLS. To see a difference, small differences, I had this GFG documentation, basically this article, which I'm going to share with you. So SL stands for Secure Socket Layer, while TLS stands for Transport Layer Security. SSL supports the Forteza algorithm. So Forteza algorithm was basically the encryption algorithm, and transport layer does not support Fortes algorithm. So basically, there are different type of hash function encryption methods that TLS supports, but Forteza does not support it now, right? And then so SSL uses the message digest to create a master secret. So basically, if you will, like in the future examples I will show you when I will be creating a TLS, so I will be writing the code. So in that I will show you what is message digest now and how earlier we used to use this message digest to create a master secret key, but now in TLS we just use a random function to create a random master secret key, right? The other thing is that SESL is more complex than TLS, and TLS is simple. Yes, TLS is basically simple because we are only using some simple hash functions, cryptography methods, symmetric cryptography, asymmetric cryptography. Although they are different processes, different layers in TLS, but it is basically easier to understand TLS, right? Third thing is SL is less secured as compared to TLS, as I've given the example of that lock thing. So it is the same thing that is trying to be said here, right? TLS is more reliable and has less latency. What does this latency means? So latency means that so earlier we used to have 2G, right? And now then we had 3G and then we have 4G. So if you remember in 3G when we were trying to watch some video, right? It keeps on buffering. So what does buffering means? So basically it is the process, it is a time taken by a packet to be sent from one place to another, right? So it was very slow at that time, but now we have 4G and 5G. So the packet speed has been increased and the latency has been decreased, right? SSL has been differentiated as I said, but nowadays TLS is widely used. This was some few examples you can say, or few differences you can say between SSL and TLS, right? Now we'll see what is simple TLS. So basically, we have two types of TLS. One is simple traditional TLS, and the other one is mutual TLS. So in simple TLS, only server authentication is done. While in mutual TLS, server authentication is also done and client authentication is also done. So in simple TLS, only the server authenticates itself to the client. Then this ensures that the client is communicated with the intended server, not an imposter. It also encrypts the communication between the client and the server, ensuring confidentiality and integrity of data during transmission. So I've already said that there were 4 points that I told you to support why we need TLS in an application. And you remember I told you that confidentiality and data integrity is one of the points, right? Why we need TLS. Fourth point is simple TLS is commonly used in scenarios like web browsing, email communication, other client server interaction where only server authentication is required. So basically, this is few points why what is simple TLS and why do we need it, right? So let's take an example also to understand the process of the simple TLS, right? So let's say there are two friends, Ram and Lucky, right? Ram sends a Lucky a random message encrypted with a Lucky's public key. So what will happen is that Ram and Lucky know each other, right? So Ram will have Lucky's public key and he will write a random message encrypted with that public key, right? Now, Lucky decrypts the message. So that message can only be opened with the Lucky's private key. So Lucky will have public key and private key. Ram knows the public key, but Ram won't know the private key. Private key would be only known by Lucky. So Lucky will decrypt the message using his private key and send it back to Ram to compare the message that has been sent from Lucky against the random one that he encrypted using Lucky's public key. So this line basically, let me explain you. So first Ram sends a message, random message to Lucky encrypted with the public key, right? And then what Lucky does it? Lucky decrypts the message with his private key and sends back. So what they are trying to do is basically they are trying to see, like Ram is basically trying to see whether the random message that he encrypted and the Lucky who decrypted that message and he's sending back to Ram, so that the message is same or not. So this is what they are trying to do here. Ram compares a message from Lucky against the random one that he encrypted using Lucky's public key. If they match, then Lucky is who he says he is, because only he could have decrypted the random message, because only he has the corresponding private key. So every public key will have an associated private key also that the person will know. So if you replace this Ram and Lucky with client and server, so it will become a simple TLS because Lucky is server and we are only performing server authentication here. So Ram will know that Lucky is the correct person. And similarly, client will know that the server is the correct one, which the client is basically want to send a request to. So I have attached this image also. So basically it is of mutual TLS. But if you see the first and second step, so this is the part of simple TLS or single TLS or unidirectional TLS, because simple TLS is only single directional. The client will try to connect to the server. It will send an hello, and then it will ask server to send the certificates, and client will verify it, and then the authentication will be successful, right? So this is an example of simple TLS. In next video, we will see that what is mutual TLS and we'll see an example of that too, right?